Tell us your name and tell us about your project.
My name is Edwin Hubble. I'm a researcher at the Mount Wilson Observatory in Los Angeles, California, where I've been using the facility and the telescopes there to observe the stars around us and try to estimate the size of our universe.
What were you guys trying to do or find?
Well, when I was first hired on at the Wilson Observatory, I was just observing the stars and recording data about them and making sure that all the telescopes and the other equipment in the lab was working properly. And specifically, I was working with our largest telescope, the Hooker telescope, which at the time was the largest telescope in the world, to focus on the stars in what we were calling at the time the Andromeda Nebula. And at the time we thought that that was just a large cluster of stars. You know, it was just a nebula. It was nothing more. But as I was looking through the telescope one night, I noticed that with the increased magnification of this larger telescope, you could tell that the stars of this nebula shone differently than the other stars in the sky. They actually shone with less brightness, less intensity. So I began thinking, like, you know, why are they doing that? And I came to the conclusion that it must be because they are further away and than all the other stars. And so I, using the idea that, different light that light would shine less brightly from further away, I was able to estimate that the stars in this nebula were actually 900,000 light years away, which is significantly further away than we thought they were at the time, and is significantly further away than even the furthest stars in our Milky Way galaxy, which is really significant because at the time of my research, we thought that the Milky Way galaxy was the only galaxy in existence. We thought that really our galaxy was, in fact, the entire universe, but here we see a group of stars further away from our galaxy, like outside of it, which would indicate that they are in fact part of a different galaxy. So from there, I began wondering, how many other galaxies are there? How many are there? And using the telescope trained on various points in the sky, I was able to personally find, myself and my colleagues, that there were at least 46 other galaxies that could be recorded throughout the stars, which, I mean, is huge. In a few years, we went from one galaxy in existence to 47, like at least 47, I should say. So it was incredible. And then also by watching all these stars and all these galaxies over time, we were able to see that the brightness and the intensity of the light from them actually continued getting lower and lower and lessened over time, which would suggest, using the same principle that I used to theorize how far away these lights were, that it would suggest that these galaxies were actually getting further and further away. So not only is our universe significantly larger than we ever imagined it to be, it's actually growing.
How fast is it expanding?
Well, I'm able to estimate. That's a tough question to answer because it's a weird way to think about it. Basically, as galaxies get further and further away, there's the speed at which they continue to get further and further away from our own increases. So it's like an exponential curve. The galaxies that are closest to us, like if they were, say, 1 million light years away, they travel at one speed. But if you double that distance between our galaxy and the others, the speed also doubles. And if you double that, it doubles again. You keep doubling and it doubles over and over infinitely. So it's difficult to say, but the way I define it, the way I'm able to estimate it, is that excuse me, the universe is expanding at a rate of 500 kilometers per parsec, and a parsec being about 3.26 million light years. So basically, every 3.26 million light years of distance, the galaxies are continuing further and further away by 500 kilometers per second.
Where did the project occur?
Like I said before, it was all the research was conducted at the Mount Wilson Laboratory in Observatory in Los Angeles, California.
What other events were happening at the time?
Well, a few years before I began my research in 1923, and in 1915, Albert Einstein released his general theory of relativity, which, of course, was a major groundbreaking, discovery in the scientific world. And also around that same time, right before I was hired on at the observatory, World War II was occurring, and World War I was occurring, and I myself fought in that. So those were two major events that happened right before, but then during my research, there was also, because it spans so many years, there were also multiple major events that occurred in it, such as the stock market crash of 1929 in the United States, and a few years following that, the worldwide Great Depression of 1934.
Who else was involved?
So it's pretty much every staff member at Mount Wilson's was involved, because in some way or other they helped me with my research, but the bulk of the research was conducted by myself and my colleague and friend, Milton Hugh Mason, at the observatory.
What was your role in the project?
So my role began, like I said, when I was first hired on. I was just tasked with keeping the Hooker telescope focused on the Andromeda Nebula. But after I started making my discoveries, I continued to head the research of studying and figuring out where other galaxies in the universe may be and how far away they might be. So I was head researcher on that my own personal project.
What impact did your project have on the physics community?
It completely changed the way that we understood our universe. Anytime you go from believing that there's only one galaxy or one of anything in existence, and then you find that there's actually potentially thousands of said thing, in this case galaxies, full of thousands of stars, that completely changes the way you look at life and creation itself. So it gave us new insights, and then the fact that I was able to show that the universe is expanding gives us all just so much more insight onto where we come from, how the universe was created, what might even be out there, and just different possibilities for future space travel.